So today our topic is purifications of organic compound. That organic compounds having some impurity. So first step that we will remove their impurities, and after that removing impurities, that second step is that detection of element. What are the elements present in that organic compound? And after that estimation of that organic compounds means how much particular element is present in that. So first we will study that purification, second after that qualitative, third after that quantitative. So in that purification you can see that there are two types of mixture. One is solid mixture and one is liquid mixture. So solid mixtures can have some examples like filtration, crystallization, sublimation and all. And for method of purifications of liquid like simple distillation, fractional distillation, under reduced pressure, steam distillation, etc. One very important characteristics for a pure substance is that it having very sharp melting point and boiling point. It having fixed melting point and boiling point. Coming to here, that first process by which we can segregate that solid mixture, that sublimation. So in that solid mixtures will be there, that organic compound. In that impurities, either impurities will be sublimable or that organic compounds will be sublimable, means directly it will change from solid to gaseous state. Sublimation process is used for the sublimable volatile. Sublimable means those which is changing from directly solid to gas. Volatile means at room temperature, which directly changes from liquid to gas or solid to gas. From non-volatile impurities, here some examples. This examples only mandatory, that is try to remember this all those: camphor, naphthalene, anthracene, benzoic acid, phthalic anhydride, anthraquinone, indigo, HgCl2, solid SO2, NH4Cl, and iodine. Coming to the second process, crystallization. This is solid liquid mixture. So in that what will happen, that you can see the first point, crystallization is based on difference in solubility of compound and impurities in a suitable solvent. Means in a particular solvent, that organic compounds and impurities having different degree of dissociation or different degree of solubilities. So this principle involves that in that impure compound dissolve in a solvent according to temperature, like aspiringly soluble at low temperature, appreciably soluble at high temperature. Insoluble impurities are removed by filtration in hot condition. So some of the impurities, what will happen after heating, it will start floating on the surface of the solution, so we can remove by filtration. And after that we will keep that saturated solution, concentrated solution, in undisturbed condition for cooling, and due to that after some period of time pure crystals will be crystallized out. Here you can see that two other extra points. If compounds are highly soluble in a particular solvent and very little soluble in another solvent. So suppose for example, try to understand, if organic compound with impurities, if it is unable to dissolve in particular solvent or very little it is soluble, then crystallization cannot be carried out properly. And same if it is highly soluble, means what, some amount of impurities also will dissolve in that. So for that what we can do for such type of situation, that we can that then crystallization is carried out by mixing this solvent. Means we will mix both type of solvent so that organic compounds will be more appreciably soluble and impurities will be either it will be floating on the surface, so through filtration we can remove, or if it is dissolved also some amount, then through mud it will be segregated out and crystals will be formed above the liquid. Next, here impurities, those which imparts color, can be removed by activated charcoal. So you know charcoals having a small pores, so in that color pigments will be stuck over here there, and then after it will be segregated out. Here one example you can see, that sugar having impurities of common salt and solvent is proper solvent is hot ethanol. So in that sugar is dissolved in the hot ethanol, but common salt gets precipitated out. Some of the common important solvents are water, alcohol, ether, chloroform, carbon tetrachloride, acetone, benzene, and petroleum ether. Coming to fractional crystallization is not that important, but yes, will do. Fractional distillation is very important, but crystallization is also. So fractional crystallization is like repeated crystallization, like making it concentrated, then after again cooling it, again making it concentrated, cooling it, like that, step by step. So process of separation of different components of mixtures by, like in that organic compound, different components are there at different degree of crystallization, they will crystallize out. So that is called fractional crystallization. Fractional crystallization is used for the separation of two or more soluble substance which having different degree of solubility at same solvent. Like you can see KClO3 and KCl, or KbRO3 and KCl. Here all those are barcodes there, so utilize this one and see that needful videos that they are on YouTube. Now coming to here distillation. So distillation having three types of distillation mainly. First one is that simple distillation, then after fractional distillation, and third one distillation under reduced pressure. So here you can see distillation is important method to segregate volatile liquid. Means volatile liquid means directly change from liquid to gas at given temperature, certain temperature, from non-volatile impurities, and liquid having sufficient difference of boiling point. So distillation can be done for those substances which having boiling point difference also. So here coming to simple distillation. So simple distillations, for that condition applied that both liquid should not break down at their boiling point. If it is breaking, then some other substance we will get after heating it at their boiling point. So that should not happen, means they should be there at their boiling point, they should be present. So vaporization of liquid by heating and subsequent condensation of vapors by cooling is known as distillations. Here some three set of examples. So for simple distillation, that it is how it is different from fractional distillation, that it is having boiling point difference either 40 Kelvin or 40 degrees Celsius, because you know change of temperature delta T is independent of a scale. So boiling point difference is greater than 40 degrees Celsius. Such type of substances only can distilled by simple distillation. So you can see chloroform and aniline, ether and toluene, and benzene and aniline. Okay, so there's three example, remember. Coming to fractional distillation. So fractional distillation, what will happen? In that like simple distillation, we will have one jar, or you can say beaker. In that beaker, at this upper part will have some glass beads. Glass beads means like a small glass plates, and then after it will be connected here through ice bath, and that vapors will pass from here and that will be condensed. So now try to understand, here liquid A is there and liquid B is there, both liquids are there, and their boiling point difference between A and B is less than 40 degrees Celsius. So when we are heating, so what happening, that let's suppose A is more volatile than B. So A boiling point is less and B boiling point is more because it is less volatile. So if we are heating at boiling point of A, that time what happening, majority of vapors of A rising up, same time some vapors of B also rising up, since their boiling point difference is less than 40 degrees Celsius. But when they are coming to that glass beads on glass plates or theoretical plates, on that they are spreading. So due to that their surface area increases, and due to that their rate of cooling increases. So those substance, let's suppose A and B is there. So here that A vapors having sufficient latent heat of vaporization, so its vapors will move on ascending orders on each glass plates, and subsequently it will pass and it will be condensed. But B does not having that sufficient latent heat of vaporization, so in descending order it will go down in liquid form due to surface area as it will cool down. So it will again dip down into beaker. So like this, by subsequent process, step by step, that vapors will pass glass beads and it will be collected over in another beaker. So you can see here, fractional distillation is used for difference in boiling point to liquid less than 40 degrees Celsius. Vapors of liquid mixtures are passed through fractionating column before condensation, which is fitted over the mouth of the round bottom flask. So vapors of liquid with high on boiling point condense before the vapors of liquid which having lower boiling point, and the vapors rising in the fractionating column is richer in more volatile component. So those substance which boiling point is less, its vapor composition will be richer, so it will in ascending order it will pass the surface glass beads. So you can see here, fractionating column provides many surfaces for heat exchange between ascending vapors and descending condensed liquid. Each successive condensation and vaporization unit in fractionating columns is called a theoretical plates. Liquid forming at constant boiling mixture like azeotrophs that cannot be separated by fractional distillation. You know, because here liquid and vapor compositions will be same. So here some examples, like in industry crude oil like petrol, diesel, kerosene, naphtha, that natural gas, all those are segregated by fractional distillation. Acetone and methyl alcohol, benzene and toluenes. Coming to distillation under reduced pressure. So distillation under reduced pressure means those substances which we are trying to segregate, if we are heating at their boiling point, what will happen? They will dissociate. Means some other substance it will be formed. Like suppose for example KClO3. If you are heating, it will break down into KClO plus KClO plus O2. So instead of that, we will do one thing, that we know that boiling point, one definition is that vapor pressure of that liquid is equal to the atmospheric pressure. So when vapor pressure of liquid equal or greater than the atmospheric pressure at given temperature, that temperature is called boiling point. So here you can see distillation under reduced pressure. When that substance is getting dissociate, then what we will do, we will keep that substance in a chamber and where we will decrease the atmospheric pressure. So as we decrease atmospheric pressure, appropriately or subsequently, that boiling point also will decrease. So as boiling point decreased, so now it will not dissociate at that temperature. So here are some examples. You can see glycerin is purified by vacuum distillation, H2O2 and formaldehyde. Sugarcane juice also is not dissociated, but yes, to save lot of fuels, what we will do, that in that chamber we will decrease the pressure, atmospheric pressure. So overall vapor pressure also decreases, so it will vaporize very fastly, so we can save lot of fuels. Coming to steam distillation. So steam distillation is that, for this condition is very important, that that this method is used for the separation and purification of organic compounds which are steam volatile, are insoluble in water and contains non-volatile impurities. Means what are the three conditions? It should be steam volatile, means on steam it should be volatile, and insoluble in water, it should be not dissolve in water, and non-volatile impurities. Non-volatile means like urea, glucose, sucrose, they all are non-volatile impurities. They are not having vapor pressures. So here in steam distillations, that it based on Dalton's law of partial pressure, that P is equal to P1 plus P2, means atmospheric pressure is equal to vapor pressure of that liquid along with that vapor pressure of water, that is aqueous tension. So again, that vapor pressure of that both liquid means water and organic solvent should be equal to atmospheric pressure, then only it will vaporize. So here that is its example is very important. They will ask orthonitrophenol or paranitrophenol, like that. So compounds which can be segregated by steam distillations are aniline, nitrobenzene, that bromobenzene, orthonitrophenol, orthohydroxybenzaldehyde means salicylaldehyde, orthohydroxyacetophenol. So orthohydroxyacetophenol means you know that benzene having acetophenol along with that at ortho OH group, turpentine oil and essential oils. Coming to differential extraction. So differential extraction is what? That it is based on solvent. Like suppose for example this is one tube, and in this tube one organic compound is soluble in one solvent. Now I am putting another solvent and then after shaking it. So after shaking, what will happen? That organic compound must be more soluble in that solvent too, just now I added. So what will happen? That organic compound will dissolve in that solvent, and that previous solvent, it will be segregated, and both solvent, that solvent, previous solvent and recently we added solvent, both should be immiscible. So it will form two layer, and then after by separating funnel we can segregate. So here you can see best here solvent we can use as a ether, which having less polarity and less reactive. Example, and higher solubility in organic compounds, because organic compounds dissolve in organic solvents only. Benzoic acid can be extracted from its aqueous solution using benzene as a solvent. Next, this although you know that terminal alkynes group, if we are reacting with Cu2 Cl2 ammonical Q plus chloride, so it will form red precipitate. By reacting with a dilute HCl, it will form pure form. Same like that, these two other substances also you can go through. Now coming to chromatography. So in chromatography, what we will do, in that actually two mediums will be there. One will be your stagnant, means it is called a stationary phase, and one is moving phase, so that is called moving part or moving phase. So two phases will be there. So here you can see chromatography is obtained from Greek word chroma means color and graphy means writing. This technique consists two phases. One is a stationary phase, which having large surface area, and second is moving phase, is allowed to move slowly on the stationary phase. So you can see a stationary phase either will be solid and liquid, and moving phase will be liquid and gas. So there are two types of chromatography. One is adsorption and one is partition. So adsorption chromatography is based on that fact that different compounds adsorb on adsorbent. Adsorbent will be means solid phase of different degree. So that different compounds that gets adsorbed on adsorbent different degree. So here you can see that adsorbent can be we use as a silica gel, alumina, magnesium oxide, cellulose, activated animal charcoals and all. So when mobile phase is allowed to move over the stationary phase, components of mixtures move variable distance, varying distance over a stationary phase, because they having different degree of adsorption. So there are two main techniques or principle which it is used for differential adsorption. As we discussed, there are two types. One is adsorption chromatography and partition chromatography. So there are two types of chromatography techniques used for the differential adsorption. One is column chromatography and one is thin layer chromatography. Means adsorption chromatography is two types. One is column and one is thin layer. So you can see by name only it is telling. Column chromatography means what? We can take one that tube, and in that tube we'll put that one liquid solution which is acting as a stationary phase, and after that we will put that mobile phase. So according to that, different degree of adsorption will happen. So here you can see mixture of adsorb on adsorbent is placed on the top of the stationary phase. So mixture of adsorbed on adsorbent means which is going to getting adsorbed on different degree is getting, we are putting on at top. So as we are putting at top, so now it will go due to gravity down. So due to that different degree of adsorption, different that marks will come. So here you can see that mixtures which is getting adsorbed on adsorbent is placed on the top of the stationary phase. The appropriate element means solvent, which is liquid or mixtures of liquid, allowed to flow down in column slowly. The most radially adsorbed substance are retained near at the top. So those substances which are more radially adsorbed, means more having degree of adsorption, that will be at top, and those who are having less, it will go down at a different variable distance. So this is now coming to thin layer chromatography, TLC. So in TLC, what we will do, we will take like glass plates, and in glass plates we will apply silica gel, that SiO2 or aluminum, and thick layer, and that will be our stationary phase. And on that stationary phase above 2 centimeter, we will keep that color pigments which we want to segregate, and then after we dip into particular type of solvent. So solvent, due to capillary action, it will rise up. So here you can see that glass plate is coated with silica gel, thin layer chromatography, and solution of mixtures can be separated, applied over the a small spot above the 2 centimeter from the TLC, like here we kept. So the glass plate is placed in a closed jar containing eluent, means solvent. The eluent rises up. The components of mixtures move up along with eluents to different distance depending upon their different degree of adsorption, and separated out. The relative adsorption of each component of mixture by expressed by this value, RF value, is very important. From this baseline, whatever that distance is covered by that substance on this stationary phase is called its distance covered by solute, or distance covered by that organic compound is, let's suppose, x. And since solvent or eluent, they are in mobile phase, so due to capillary action they will rise up more little bit. So let's suppose their distance from baseline is y. So retardatory factor is always less than 1. So retardatory factor for this pigment, what it will be, x by y. So distance moved by the substance from baseline divided by distance moved by solvent from the baseline. So the spot colored compounds are visible on TLC plate due to their original colors. Sometime what will happen, colorless compounds, so due to that fluorescence or UV light we will pass, then we can detect. Or sometime we can spray it on that hydrogen solutions and other also, so that we can detect their marks. So spots of compound can be detected by allowing them to absorb iodine. So due to the iodine, brown spots will come, brown or black. Sometime appropriate reagent also sprayed on the plates, like here you can see amino acids are detected by spraying the plate with ninhydrin solution. In amino acid we studied ninhydrin solution. Now coming to partition chromatography, which you have studied in 9th class also. It's one example here we have to study paper chromatography. So same like that, thin layer chromatography. Instead of glass and applying silica gel, we will take that cellulose paper, again 2 centimeter above, like that we can keep. So here you can see chromatography paper is spotted with solution of mixture at the base and suspended in the suitable solvent, which is mobile phase. Solvent rises up due to capillary action and flows over the spots. So paper selectively retains its different components according to different degree of adsorption and forming two phases. So the paper strip is so developed is called chromatogram, and the spots which is separated colored compounds are visible at a different height from the initial spot of the chromatogram. Again like that, their color substance may be observed either through UV light or by using appropriate spraying agent. Clear? So this one. So here we completed. So what are the topics we completed here once again? So first we discussed that that solid, in that we discuss simple distillation. After simple distillation, I told that remember that all those examples. After that we started that fractional distillation. So fractional distillation means those substances uh, which we can say means different type of different components can be segregated at different temperature. So like that, here it is. So crystallization, then after fractional crystallization, after that we did distillation. In that simple distillation, so boiling point should be more than 40 degrees Celsius, it should not dissociate. Then after fractional distillation, in that glass beads having main use. Then after vacuum distillation, after that we did steam distillation. Then after through solvent, different solvents having different degree of solubility of that organic compounds, and both solvents should be immiscible. After that after that we discuss chromatography. In that adsorption chromatography having two types, column and thin layer chromatography. And column chromatography, in that substance organic compound we are putting from top in the column, remaining all having like plates dissolving in the mobile phase or that solution. So due to that it is rising up through capillary reaction, and different degree of adsorptions are segregated on the plates, so by which we can separate that organic compounds from its impurities. Thank you very much. Now we will discuss second segment, that is qualitative analysis.